This is how you must write it. Lowest number on the left. Okay? And then less thans and less thans. Everybody cool? All right. That's domain. Range only cares about which? Excellent. So since it only cares about the y-axis, does it matter that the line starts there and only goes to there? Does that matter? Yes, because I am only caring about the y-axis. So I need to be aware that there is a y value all the way up to there. The lowest y value, -1, less than or equal to y, less than or equal to 1, 2, 3, 4. How else can I write it? -1, 4 with square brackets, because both are included. Do you understand? Okay. So the people in the first class were having trouble with anything that was curvy. So that's why I'm doing the curvy ones. So let's have a look at this one. What is the domain? What is the lowest x value? Right there, correct? -1, 2, 3, 4, 5. -5, less than or equal to x. And what is the highest x value? Right there. 5. Because that part is what is covered. The range only looks at the up and down. -1, 2, 3, 4, 5. Hey, -5. Y, and it goes up to 1, 2, 3, 4, 5. 5. That's the range, because it's only on the y-axis. Okay? Now, what happens, for example, in number 4, where you notice that arrow and that arrow? Forever, right? So this part of the line is covered, and it continues that way, doesn't it? Now, what happened there? It stopped, but it started again right here, yes? So is this still part of the domain? Yep. And then it stopped. Oh, but it started again right there. And then it started again right there. And then it goes on forever. Yeah. So it goes -infinity, x, positive infinity, bracket infinity, -infinity, bracket infinity, or even easier, shorter way to write it, x, and then we use this big letter E, which you guys don't need to know till later in life, but it means is a set. X is a set of all real numbers. Every single number possible is going to be on this graph. If I could draw this graph out to infinity, that line would be on it. Got it? Okay. But what about the range? The range only cares about the y-axis, yes? Is there a y value there? Anywhere else? Right there. Anywhere else? Right there. Anywhere else? Right there. Did I color in any part of the y-axis? No. So the range can only be -3, 0, 3, 4. I can't do anything else because I didn't cover any section of it. Is everybody okay with domain and range now? Yes? Yes? Okay. All right. That makes me happy. I have an answer.
So, why that is not like the letter T and 146?
On 146. 146 right here. Which letter? D. It was like that. See? 3, 6, 9 for range. And domain only went from that spot to that spot. If, Giovanna, this had an arrow there and an arrow there, then this would have been infinity to infinity. Okay? Isha.
For 3 on page 150.
3 on page 150. Yes?
You have to do the union thing, right? Or do you not?
You do not have to do the union thing for domain. You have to do it for range.
Can we go over that one?
Yes, I can. That is a math teacher's dream when kids ask questions and we can do something about it. So, domain has that arrow, yes? So everything that way is on it, yeah? Up to here, where it stops. Agreed? So my x's have to be less than or equal to 6. Every x that is less than or equal to 6 will be on this graph, yes? Right? If I want to finish that, it would go down to negative infinity, but I don't need to bother because anytime infinity is involved, it's just all the x's less than 6, right? You cool? Just a shorter way to write it. You good? Okay, now, range. I only care about the up and down. So there's a range value right there, right? What is that? -2. Is that a closed dot? So is it included? Yep. So -2 less than y, and it goes up to what? No, that's positive. +1. Closed dot, yes? And then it happens again up here, doesn't it? But it's only got one value, right? What is it? 4. So this is part of the set. -2 less than or equal to y less than or equal to 1. And there's another element to the set. 4. For range only. Good? Union. Because there's more than one set. Got it? People happy? Like Pharrell? Okay. No, Pharrell, the singer. Will Ferrell is the comedian. Pharrell sings the song. Happy. Will Ferrell makes people happy by making them laugh.
He's the elf guy. We should watch him.
No, we shouldn't, because this is not cinematic appreciation 10. This is math 10.
We should do some math instead.
We should. All right, we all good with domain and range now? Happy? Okay. Move on to page 151. Now, you guys already know how to answer every question there, but you may have a little bit of trouble with the first one. Identify the dependent and independent variables. Well, the dependent and independent variables are the two things that can change on a graph, right? That's what variable means. It changes. Yeah? Okay, so what are the two things that this graph has that change over the course of the graph? Brianna. Okay, so the depth changes and the time changes. So we know there are two variable values here, yes? One of them must be independent and one of them must be dependent, correct? Which is which? Talk to your neighbor. Do not yell out an answer. Decide. I have already gone over why independent variables are independent, why dependent variables are dependent. It is in your notes from a couple of days ago if you wish to go back and check if you don't remember. Yeah, righty then. Which is which? Who would like to volunteer their estimate or guess? Isha.
Depth is the dependent and time is the independent?
Depth is the dependent variable. Time is the independent variable. Now, stop for a moment. Everybody was able to come up with something, I hope. How many of you knew that this was right because you had a graph? Because earlier in the semester, this unit, I discussed how the independent variable is almost always graphed on the x-axis, yes? So a great many of you said, got you, Mr. Myers. Yeah, that's the independent variable because it's on the x-axis. Agreed? Okay, now, watch. Could I not have made the graph look like this? Could I have changed these to this? Right? And then graphed it sideways. As my time went up, my depth went. So I would have gone this way. 4 up to 12. Could I have graphed it that way?
No, because time doesn't go backwards.
Excellent. Time does not go backwards. Lovely. But what if I had stopped right there? Now, what's the independent variable? Well, it's depth. It's on the x-axis, Myers. Duh. So, once again, I remind you, is it better to learn why or better to learn what? Why. So I'll ask again. Why is time the independent variable? No. You're very close, Josh. Well done. Right now, are any of you underwater?
I hope not.
Nope. Is time passing for you? Excellent. Did time just pass some more? How far underwater did you go? Not at all. Understand? Time is independent because no matter whether you are diving into the ocean or not, time is still passing. It is independent of the other one. The people on the boat with this diver are still passing that time. Do you understand? That is the point of this question. I need you to understand what it actually means. Their depth underwater as they swim down depends on how long they are swimming down for, right? Okay. Now, let's see if you guys can read this bad boy. How long did the dive last? How long was this person underwater? 30 minutes. Excellent. Well done. Is that... No, we'll leave it at that. Did this diver at any point stop swimming downwards? Josh. Only between 10 and 14?
4 and 8. As well as 4.
Thank you. She stopped between 4 and 8, and she stopped between 10 and 14. How did you know that she stopped descending?
Because the line goes straight across.
The line goes flat because at those 2 points, only the IV changed. Why did the IV continue to change? Why did the independent variable continue to change? Because it has to. It is independent of whatever she is doing under the water, isn't it? Right? Here, she found Dory. Here, she found Crush.
Oh, no, you see.
Right? But in between them, time continued on, and she swam deeper. Got it? Lovely. What was the greatest depth which she attained? 20 meters. And how long did she stay at that depth? 4 minutes. Now, let's see if you have indeed learned something. What is the domain and range of this relationship? Wait, that was the wrong word, because this is indeed a function, isn't it? So, what is the domain and range of this function? Go. Would anyone like to volunteer their answer? Yes? No. 0 to 30. Excellent. What goes in the middle? X?
Minutes or time.
T for time. Nice, because the domain here is not x's. These are not x values. They are values of time. Lovely. What is the range? Nice. 0, less than or equal to, less than or equal to 20. What should go there? D for depth. It is measured in meters, but it is the depth is the domain, or is the range. Okay? Now, the question becomes, is this graph a drawing of what actually happened, or is it a representation of the data? It is a representation of the data. Because when she jumped off the boat, what direction did she really go? Down. What direction did the graph line go? Up. Does everybody understand? Graphs represent data. They do not draw the picture of what happened in real life. Because in reality, except she's wearing a wetsuit. And she has on one of those big Scooby-Doo ones so she can talk to her friends. She jumps off the boat, and she goes down. Does she go down on an angle? No. She goes straight down. Why is this an angle? Because it's representing data, and time is passing. When she gets to here, there she meets Dory. Hey, Dory. She hangs out with Dory for a while. Then what does she do? Continues going straight down until she visits with Crush. Except Crush was totally a surfer stoner, so tough to keep it. He was eating because he ate seaweed. Seaweed. All right. Gouda? All right. So, we've covered a bunch of stuff there now, yes? Everybody can read a graph. Agreed? Okay. Now I'm going to give you 1 minute to describe the real life situation that this graph is representing? Whatever you need to do. It's every class. I'd like you to get it out of the way. What next? Go. Talk to each other. Figure out what this graph is talking about in real life. Give me a scenario about it. Of course. It's not like we didn't just give you 6 minutes to do that or nothing. Mr. Myers, I don't know why I'm no good at math. Hey! Who would like to volunteer their story? Go ahead, Jashin.
So, she picks up a water can, and her can water in it, and then she pours it out, and then she walks to the flowers, and then pours it all on the flowers.
So she picks it up.
So she picks it up, there's already like
Half
1 liter.
Okay.
There's already 1 liter in it.
Yep.
So she fills it up.
Uh-huh.
Hey, this was my story.
So she fills it up.
Yeah. And then she walks the plants.
Okay.
So that's the time going second, and she dumps it all the flowers.
Excellently done. The gardener, whomever it is, picks up a watering can that has 1 liter of water in it. Right? So from A to B, the gardener fills the bottle. Fills the watering can. Right? Great. From B to C, the gardener does what with the water in the can? Nothing. So I got to think something's happening though, because time is passing. So Jashin says she or he is walking to the flowers. And what happens from C to D? Dumps the water. Everyone agree? Okay, now we got to talk, as always, the first graph led us to be able to do this one, yes? Now we're going to do something with this graph that is going to help us on the next graph. What do you notice is happening from here to here? What is changing? Jack. The amount of water in the watering can is changing. Indeed, it is going from 1 to 1.75, yes? Excellent. What else is changing? This is going up by 0.75. Agreed? What else is changing? The time. What is happening to the time?
It's passing.
At what rate? How many seconds? 30. Agreed? So, what do I have there? I now know that in 30 seconds I can fill the water bottle 0.75 of a liter, yes? So that is saying I am doing 0.75 of a liter per 30 seconds. That is what we call a rate of change. Or, as you guys know it in regular language, a speed. Understand? Except we don't measure speed that way, do we? How do we measure speed? Give me a measurement of speed. Jack. Kilometers per hour, right? So we do a distance divided by a time, yes? A single time. Would you ever tell somebody, if the cop asked you how fast were you going, well, officer, I was going 60 kilometers per half hour. You're going 120 an hour, right? So does this rate of change make sense mathematically? Yes, because we can see 0.75 and 30. What would we say the rate of change is there, though? Would we do it per 30 seconds, or would we do it per minute, or per hour? Per second, maybe. If we were doing it per minute, what would it be? 1.5 liters per minute. How did you know that? Because you had to multiply that by 2 to get to 1 minute, yes? And what you do to the numerator, the denominator, you do to the numerator. Excellent. What if I was doing it by the second? What would I have to do to 0.75? Divide it by 30. Everybody good? That's a rate of change. Everybody cool with it? Okay. So that's the fill up rate of change, 1.5 liters per minute. What then is the rate of change on drainage? You guys figure that out. The drain rate. What changes? How do you figure it out? Would anybody like to volunteer? What do you think it is? From the graph, you should be able to get it exactly, right? How much water comes out of the watering can? 1.75 liters. In how many seconds? 20. 70 to 90. Now, that's the actual rate. Is that the rate that we would use in real life? Again, I ask you, do you tell the cop I go 45 kilometers per half hour? No. So what is this really? 3.25? 3.5 liters per minute. Which is faster, the drain rate or the fill rate? The drain rate. The drain rate was 3.5 liters in a minute. The fill rate was only 1.5 liters per minute. Oh, sorry, by 3. Thank you. So it is 3 3/4 times 3 is 9/4, which is 2 1/4. It's 5.25 liters per minute. Everybody cool? Everybody cool? Okay. How is it represented on the graph? Which is the faster one? The drain rate, which is significantly steeper slope. Does everybody understand? Right? Now, technically, when this went down 1.75, should it not have been negative? I'm draining it. But didn't I lose? Picking up what I'm putting down? And what did I gain here? 0.75 was added. Please notice there are two distinct measurements there, isn't there? One of them tells me how much came in or out. How much. The other one told me which direction it went. Does everybody see the difference? Okay, that's very important. Go on to the next question and let's do this. Now, listen to me please. It is imperative that you draw this in pencil because 90% of you are going to screw this graph up. Okay? Try to draw. You have all the information you need to sketch this graph fairly accurately. You may work with a neighbor. I will give you 4 minutes. Go. I have given you nothing but axes. You will notice that these axes do not go into the negatives. There's a reason for that. Go. See if you can figure out how to do it.
Okay, I thought it was going 140. That's at that constant. That's what we're supposed to do.
1 more minute. You don't need a ruler, just sketch it, man. Just sketch it. No stress. Just sketch it. I know. So you have to make some assumptions. What? Batman, it is. Okay, so I'm going to use 4 different colors because there's 4 different stages of the trip, yeah? First of all, I have to decide how I'm going to graph this. What is going on the on the x-axis? Time, because time is independent. So I'm going to put time down here. And as my good friend Sam said, he's going to break it into hours. I did. That's exactly what I was doing because Max sits over there. I need a little more than 5, but that'll do. Now, what do I need to make sure I include when I make this scale down here and I say that it is time?
1 hour.
I need to tell you that it's in hours, yes? 1. This is time in hours. Because if I don't tell you it's time in hours, you have no idea what I'm counting there, do you? Excellent. What goes on the vertical axis? In what? km. I'm going to go up by 20. 2, 4, 6, 8, 10. There's 100. 2, 4, 6, 8, 20. There's 200. Is everybody happy with that? Okay. So the first part of the graph, which I'm going to draw in black, says he leaves home and he travels 2 hours and he goes 140 kilometers. So I need to come out to 2 hours and be up at 140, yes? Does everyone agree? So the line between them, since it's constant, must be pretty straight. Yes? How fast did he drive? 70 kilometers an hour. Because it's 140 divided by 2. We would never tell the cop, oh, let's go at 140 kilometers per 2 hours, sir. It's per 1 hour, right? Okay, so everybody's cool with that, yeah? Everybody has that for their first bit. 2 hours passed, he went 140K. Cool? All right, now I'm going to change to red. Visits grandma for 1 hour. What kind of line has to happen there? Flat for 1 hour. Why? Because distance isn't changing. He's sitting drinking tea with grandma. Yeah? Yeah. Now here is where a bunch of you are going to make your mistake. Did your line now go up or down? How many of you drew the down line? Hands up. How many of you drew the up line? Hands up. Okay, now. Everybody, close your eyes for a moment. Everybody, be honest. Help me out. Look, actually, open your eyes. Look at me right now. Everybody see where I'm standing? Okay, close your eyes. Be honest. Be honest. Close your eyes, Yunji. Don't be that way. Be honest. Close your eyes. Open your eyes. Only Mason cheated. Open your eyes. How far did I travel? You have no idea. Why? Because I'm back where I started, yes? I am telling you right now I moved. Do you know how far I moved? No, because according to you, I have not budged. Your eyes were closed, yes? But I really took 2 steps that way and 2 steps this way. So how much distance did I cover?
4 steps.
4 steps. So my body is now there's 4 more steps of mileage on my body, isn't there? So even though it looks like I didn't move and I'm back where I started, did my distance traveled continue to rise? Yes. So even though I am turning back home, I must draw this line upwards because I am still adding distance traveled. We're going to talk about that in a minute. We're going to finish the graph first. So I went up. Now, Riley makes a good point there. Myers, you didn't give us a speed. So what is a safe assumption to make? We know that Jack drove 70 kilometers an hour for the first 2 hours of his trip. We know he's going home. How fast do you think he's driving? No, he drives 50 kilometers home. Not a speed, that's a distance. So we assume he's going to drive 70 kilometers an hour. So he must have this same slope, yes? So it's going to go this way for 50 kilometers. Will that take a whole hour? No, because he's going 70 kilometers an hour, yes? So he's going to go at the same slope here. And then what does he do for 30 minutes? Eat supper. So is he adding any distance? No. So he flattens out for 30 minutes. Is everybody cool with that part? Okay. Now some of you will have this, and I'm going to draw it with the highlighter blue. And that's okay. All right? We'll talk about that in a minute. Now, what happens after that? He leaves, and now, even though he's 50 kilometers from home, it's still taking him 2 hours. So is the line the same, steeper, or shallower? It has to be shallower because he's still taking 2 hours, but he's covering 50 kilometers less distance. Does everyone understand? So he's going to go for 2 hours at a lower slope. Is everybody cool? And then down here, I'm going to use the highlighter green to get back home. Is everybody good? All right. This is distance versus time. And distance is what we call scalar, because it only has what we call a magnitude. A magnitude is an amount, okay? Your height is a magnitude, because whether you are standing on your head, lying down, turning cartwheels, your height never changes. Understand? So it is what we call a scalar. This one down here is what we call displacement versus time. Because displacement is a vector, which means it has a magnitude just like distance, but it also has a direction. Now, in the real world, how many different directions are there?
4.
Yes, a lot. Infinite, isn't there? There's all the possibilities in a circle. Left, north, east, west, south. There's up, down, left, right, towards, away. Right? So in reality, there is an infinite amount of directions. How many directions is there in math? 2, positive and negative. So, vectors have a positive value or a negative value, and they depend on the viewer. And let me give you some examples. I will be using visual aids now. But before I do so, I will be talking about positive and negative values. Math and science people have decided on the following. Positive values are north, west, up, right, or away. Now we've already said there's an infinite amount of words we can use there. Those are common ones. Everybody cool? So if you move away from your starting point, you have a positive displacement. Does everybody understand? Okay? Now, negatives, duh. What's the negative counterpart of north? South. What's the negative counterpart of west? East. Actually, wait. Never eat soggy wieners. That's the other way around. I was thinking, yeah, it's east and west. Sorry, guys. What's the opposite of up? Down. Right? Left. Away. Towards. So, let's see if you guys really understand this. From your perspective, because you're the viewers, tell me my displacement right now From your perspective, what is my displacement?
Away.
3 steps is a distance. You didn't give me a displacement. Displacement is a vector. It needs a direction.
Away.
It was to your left. So what was it?
North.
That's technically north, but since you guys don't know which way is north and which way is west, since you're arguing about it right now, what is the only thing you know here? You only know left and right, correct? So from your perspective, because you're the viewer, what was my displacement? And left is what? Left is not a math thing, guys. Oh, I didn't hear you, Tasha. I only heard left. So negative what? Negative 3. Everybody cool? My displacement is negative 3. Jack, what is my distance traveled right now?
4 steps.
3.
3 steps.
No direction. Everybody with me? Now, when I go back to where I started, that is now positive 3 steps, yes? What is my total displacement? 0. Negative 3, positive 3. 0. What is my total distance? 6. Wait. Now what? Total displacement. No, displacement is a vector. Total displacement. Negative 2. Total distance. 8. Does everybody understand?
I don't understand how you're making it.
Okay. Do you understand how I went negative 3?
Yeah.
0. So for you guys, I screwed up because I'm going left. I forgot. For you guys, I'm taking 2 more steps this way, so I should have been positive 2. Thank you. It's because of me, because I'm thinking left, right? I needed to turn around. But then you're looking at my ass, and I don't want that. Okay? Everybody with me? Still 2 displacement, but 8 distance. Positive 2 displacement. Everybody good?
Yeah.
Now, if we were doing that from my perspective, what changes? The 2 or the 8?
2. The 2.
Only the 2, because I still did 8 steps. Distance doesn't have a direction. From my perspective, I am now at negative 2, because I moved 2 steps to the left. Does everybody understand? Yes? What doesn't make sense, Sam? Huh?
0 divided by 0.
Oh, 0 divided by 0 doesn't exist. Everybody cool? All right. Now, look at this question and see if you can do this scenario. Look closely, because you might screw it up. Yep. Alrighty. How many of you actually checked what was being measured? It's speed versus time now. It is not distance. Jack, what is happening?
So, Alicia
Okay, so again, you guys are falling into the trap of not looking at what's actually happening on the page. You are falling into the trap of, this is what it was like right before, so it must be the same thing here. Right? Lexi. Oh, double Lexi. Oh, see if you can do it this way. You say one word, then you say one word. And see if you can explain it. I'm just kidding. Lexi, you go first, and then that Lexi.
So she runs 8 meters per second, and then she stays at 8 meters, and then she floats.
Okay, what were you going to say? Just what she said, so you guys could have done it. She runs at. Okay. What happens here? How fast is she going at 0 time? She's not running at all. She's at the starting line, isn't she? So, what is your speed at the starting line of a race? 0. So from 0 to A, she's standing still. No, I lie. She's accelerating. Accelerating is a bad word. Physicists don't like it, but I use it because we're not in a physics class. Accelerating to what speed?
8 meters per second.
To 8 meters per second from a standstill. Yes? Because she's standing at the starting line, wait for the gun to go off. Then she takes off and gets up to her top speed as fast as possible. What happens from A to B?
She runs at 8 meters per second for 14 minutes.
She runs 14 minutes? Whew.
Oh, this is a sprint.
Yeah, 8 meters per second is fast, dude. 8 meters per second is 25 kilometers an hour.
Wow.
Yeah.
8 meters per second.
Yes.
She can't run fast.
Yeah, she can. A top speed for a human is about 36 kilometers an hour. That's Olympic 100-meter sprinter. No, you can't, or you would be in the Olympics. 8 meters per second for how long? From 2 to 14. So for 12 seconds. What happens from B to C? She slows down and stops. Why isn't it a straight down line?
Because she's still moving.
Time continues to move. Even if she ran into a wall, this would still be a very subtle slant, wouldn't it? Because for a split second, she is slowing down from full speed to 0 as she splats into the wall.
That would hurt.
Do you understand me? Okay. So now you guys have to be aware. Remember, I warned you in the very first graph. The graph doesn't draw what is happening. It represents the data. How do you know what data is being represented? They tell you on the axes. Everybody got it? Okay. I am going to ask for you to do page 153 tonight. You have to draw 4 graphs. Now listen. You need not get out rulers and measure. They can be sketched just like this guy was. Now, the other thing to remember, 5, 6, and 7 are all going to be about the same, right? Because they have a right or a wrong way to do it. Number 8 is slightly different, isn't it? Because number 8 is you, how you get to school. So my graph will be different from Jake's, whose will be different from Josh's, right? Everybody understand? If you walk, yeah, unless you take the same bus. But even then, unless you were starting from the exact same spot, right? It would still be different. Everybody cool? And I'm giving you 20 minutes 18 minutes right now. You could probably get the first 2 out of the way pretty quickly. Everybody good? Go.